Hey, what is going on, guys? Welcome back to the last and the final episode of the Q Learning series. In this episode, or the tutorial series, what we are going to do is we are going to create an instance of the class that we have created, the DQN agent class, and we are going to sort of take most of the logic from the previously built the basic Q learning, the first tutorial episodes, and we are going to train and predict the model side by side. So in this tutorial, this will be the last tutorial, and I hope you guys have learned something from these series, and let's just get started. So so in the previous episode where we ended up, our tutorial is creating a method which returns the predicted q values. So given a state, its job is to predict the q values of that particular state. And of course we we normalized and then passed it to predict function from the model, and then we got the zeroth index of that particular list. As this thing, the whole thing returns a list, and we want the zeroth index of that particular list. So now what we are going to do is we'll create one more file so that we keep everything organized. So we will say this as maybe run.py, where we actually do all the training and stuff. So now let's just import few things. Let's just import all our classes. DQN import. Oops. Import. What was that? We need we need the create model. You know what? Let me just go ahead and import everything. Import DQN. All right, and then I think that's about it. Maybe even let's just go ahead later and then do our imports. So let me just say agent equal to dqn dot dqa agent, right? And now for let's just create few uh, constants, uh, all of these. Maybe let's just copy and paste these. This is from the first episode, if in case you are wondering where is this from. This is from the first episode. In case you guys haven't checked it out, I highly recommend you do. So for episode SODE in in range, oops, in range of, you know what? Let me just also go ahead and import TQDM. Import TQDM. TQDM. All right. Then for let me just TQDM this. All right. Now it's much better. So for TQDM, in the range of 1 till episodes plus 1, right? And we're gonna say ASCII, ASCII equal to true for Windows. It's T with caps. All right, and then unit equal to, let me just say episodes. All right, makes sense. What is the problem? For episode in range of TQDM is not callable. Oh, my bad. Oops. So it's from tqdm, import tqdm. Yeah, that my bad. All right. So for episode in the range of 1 till the episodes, right? So what I'm going to do is I'm going to say episode reward equal to 0, and then say step equal to 1. This is so far so good. And then let me go ahead and grab the current state equal to, yeah, and then we have to import gym, and also we need to import this, the mountain car environment. Hope it makes sense. All right, so the current state equal to env.reset, so that we just start off fully fresh, right? And that makes sense. And let's say done equal to false. Oops. Let's say done equal to false, right? And while not, I'm just gonna create some space. So while not done, right? So while not done, the same thing. If np dot random, okay, let me go ahead and import random as well, and np. Oh, I don't think we need random, but anyway, let me just not bother too much. Dot random. np.random.random. If it's greater than or epsilon, I guess I have to set the epsilon as well. Right, so if it's greater than epsilon, oops, numpy as np. Alright, so if np.random.random is greater than epsilon, so I'm going to perform the action. Action equal to np.argmax of agent dot the get queues, right, of the current state. Right, so far so good. If that's not the case, I'm gonna say else action equal to np dot let I'm just going to perform some random action, so I'll say env dot action space dot sample. So what this does is it's going to perform some action from the number of from the different actions available, right? If you go ahead and take a look, that's exactly what we are done. So we are taking the maximum q table value, right? If it's greater than epsilon, else we are going to do some random action just to account for our random movement to account for the epsilon decay. Okay, cool. And all right. Okay, so I'll say new state, or I'll say observation, or I'll just go ahead and say new state, comma reward, comma done. New state, comma reward, comma done is equal to env dot step of the action, which is pretty much the same. So reward and info is equal to actions. I'm just showing this because I just want you to get the reference as to what we are doing, because this is pretty much the same. Now since we have created the model, we are just left out with doing the actions based on whatever the model predicts. That's it. So far so good. All right, and then after that I'm gonna set episode reward. Oh, I said reward. Wow, stupid jerk. All right, So that I would set it to reward. All right, cool. And we're going to say if 2500 mod episode if 2500 mod episode is equal to 0, then I'm going to render env dot render, or else just keep going because we don't want to waste too much time. All right, okay, so far so good. And then after that we have to update our replay memory. So I'm going to say agent dot update. Now you can see how these functions are all coming in handy, functions or method or whatever you want to call it. So we're going to say update replay memory, and we have to pass a bunch of tuple values. So that is the current state, the action, the reward, the new state, and whether it's done or not. All right, so this we are going, and if you click on this, this is what it does is it simply appends to the replay memory of whatever it pass, and this replay memory itself is a DQ. Where is that? Yeah, it's a DQ data structure, right? So it is just going to keep appending those values, at least until we have enough values to start training our model, which makes sense, right? So the next is to, once we have populated enough training data, we are going to train the model, right? So we're going to say agent dot train, and then say mdone equal to done. All right, so this is going to train. All right, and then we say update the current state, right? So current state equal to the new state, and the new state we are getting from the step. All right, so that's fine. That is sensible, and we have to, so we're going to say ep reward dot rewards dot append. So what we are essentially doing here is we are appending all the episode rewards, whatever the reward we got from doing these actions, we are going to append that. Or let me just create that list, ep reward equal to an empty list, and I'm just going to append its rewards. Okay, so far so good. And what we will do is, if we want to find out the average reward, right? So how do we find out the average reward? We can do this. If episode, we will say if not of episode mod 50, let's say, if that is the case, or episode is equal to 1, right? If that is the case, we will say average average reward equal to, what is average reward? It's the sum of the EP rewards of a negative 50 up until everything, and divided by the total length of episode rewards of 50 from everything. So now what I'm doing is I am getting the average reward by taking the sum of all the rewards that I just appended to the list divided by the length of that reward. So that gives me the average, right? And also, yeah, so that gives me the average. So that's that is fine. And let me also query for min reward. Min reward is equal to minimum of the episode rewards of the same thing, 50 up until everything. So I'm querying for that, and I would. So what I'm doing is, if episode mod 50, or if the episode turns out to be 1, I'm going to do these. I'm going to take the average reward and the minimum reward. All right, and I would say if min reward is greater than or equal to, right? If that is the case, if min reward is greater than or equal to negative 200, that is, if the minimum reward itself is greater than this value, this is just an arbitrary value. And guys, all of these values are completely arbitrary. You are welcome to take whatever values you want. You can, this is somewhat like tuning the hyperparameters, so you are welcome to do that. All right, so min reward is greater than equal to a negative 200. If that is the case, I'm going to go ahead and save the model. So agent dot model dot save, right? I'm going to say uh, q learning model dot model, q learning model dot model. All right, so just in case, I want to save the model so that we can use this model to predict and go ahead again for further use if wanted. And we'll also account for our epsilon decay. If epsilon is greater than, if epsilon is greater than 0.001, right? If that is the case, we are going to do some epsilon decay. All right, so if epsilon is greater than 0.001, I'm going to say epsilon times, or epsilon is equal to epsilon times 0.001, and then I'm going to say epsilon equal to max of 0.001 and the epsilon. Hope it makes sense. And then we are already accounting for our epsilons here, just to take some random actions. All right, so I think that is pretty much it. uh, I think we are ready to go ahead and train the model.